Hi, the name of this lesson is Proven Lines Parallel, and it just kind of builds on some things we've talked about over the last few days. So we want to determine what happens to corresponding angles, alternate interior, alternate exterior, and same side interior angles when two lines are cut by a transversal and those two lines are parallel. So first, let's look at this first picture here, and you see that we have a transversal. Okay, here's our transversal, and we have two additional lines that they intersect, but these two lines do not appear to be parallel, and there's nothing that tells us they are parallel. So in a picture like this, we do still have vertical angles that are congruent, because remember, vertical angles are always congruent, and we also have our linear pairs. And our linear pairs are two angles that add up to 180 degrees on the same line. So vertical angles, we have 1 and 3, 2 and 4, but on that same part of the angles, we have 1 and 4, 1 and 2, 2 and 3, and 4 and 3 that are linear pairs. And we have the same relationships in the bottom group of angles. But this is asking us to look and name a pair of corresponding angles, alternate interior, alternate exterior, and same side interior. So hopefully you can do that now. Remember, the corresponding angles are the angles that we say are in the same position. So same position, that would be angles 1 and 6. Okay? Now, because we have this transversal, we can name the angle pairs, but we don't know anything about their measure because the two lines that are intersected by the transversal are not parallel, but those are still corresponding angles. We have alternate interior angles, so that would be 3 and 6. We have alternate exterior, that would be 4 and 8. And then same side interior might be angle 3 and angle 5. Okay, so we still have our special names, we just don't have any properties that exist with those. But now we're going to name some postulates, so let me define some terms for you. Okay, we have postulates or axioms. We can use those words interchangeably, and they're statements that are assumed to be true. We do not have to prove them. Then we have theorems, which are statements that we can prove with postulates, axioms, properties, and definitions. It's not super important at this point that you really differentiate which are which, but you do certainly need to at least know the terms. So we have the corresponding angles postulates. So we don't necessarily have to prove this, but we're telling you that you can assume based on parallel lines that if you have corresponding angles, that in this picture the measure of angle 1 is going to be congruent to the measure of angle 2 because of the corresponding angles postulate. Okay, so now let's look down here and we have an example. If A is parallel to B, which pair of angles are congruent by the corresponding angles postulate? So you look at a picture like this and you just name the corresponding angles. And so that would mean that angle 1 is congruent to angle 5 because they're corresponding angles, as well as we could say that 3 is congruent to 7. We know that 2 is congruent to 6, and 4 is congruent to 8. Okay, I'm going to put a little kind of a shortcut here that's going to help you learn some other angle pairs as well. Let me scroll down to the next picture actually. Okay, here we have the measure of angle 2 is equal to 76 degrees. So if this is 76 degrees and they want to know what's the measure of angle 6, well, we know that it is also 76 degrees because they're corresponding angles. Okay, if you notice, I put B's and L's on my angles. I have two parallel lines and a transversal. Now what the B stands for is that stands for big angles. So if you look, angle 1 and angle 4 are vertical angles. We know that they are congruent. And then 4 and 5 are alternate interior angles, so they're congruent. And then we have another vertical angle. So if you look at this zigzag pattern, until you learn all the names and properties of these angles that you'll be able to remember, we know that those are all going to have the same measure. And then likewise on the ones where I put L for little angles, those are also going to have the same. So if you can learn this pattern and you could put it on your angles, and big and little are meant to be descriptive, but you could have just as easily used X and Y. But every B is going to have the same measure. Every L is also going to have equal measure, but every B plus L will be equal to 180 degrees. So we can learn that pattern. So we can, based on knowing that angle 2 was 76 degrees, we know that every angle here that has an L is 76 degrees. And then we can subtract 76 from 180 and get 114, and that means that every angle here with a B on it is 114 degrees. So when we have parallel lines in a transversal, if you know the measure of one angle, you can give me the measure of all the angles. Okay. So now let's scroll down and we see the alternate interior angles theorem. And they ask us to find the measure of angle 1. Okay, when we look here, we know that angle 2 is a corresponding angle, and so we can say that that angle is 115 degrees because it's corresponding to this one here. And then by the vertical angles theorem, we know that this one has the same measure. So now, alternate interior angles theorem. If two lines are cut by a transversal, then their alternate interior angles are congruent. So we start to see the pattern here. And now we're going to give a proof of the alternate interior angles theorem. So what's given, what our given statement is these two lines are parallel. That's given by the markings. So we can say that L is parallel to M, and that would be our given statement. We're wanting to prove that, we were wanting to prove that that 3 is congruent to 6, okay? So we have these lines being parallel, and we want to prove that 3 is congruent to 6. So we can start by saying that angle 3 is congruent to angle 7 because those are corresponding angles. So the reason would be the corresponding angles postulate. Then we can say that angle 7 is congruent to angle 6, and that is because those are vertical angles. So we can use the vertical angles theorem. Now, if you remember from earlier, we have 3 being congruent to 7 and 7 being congruent to 6. And so since we have two different angles that are congruent to the same angle, then we can say that angle 3 is congruent to angle 6 by the transitive property. Okay? And so right below, they've written this actually in the form of a proof. Okay? So let's look here, and there's our proof. You're going to be asked to try and do some proofs in the practices. Just try your best. I know they're tricky and we can go over them, but see if you can fill in the missing ones. Okay, now we have our algebra connection. We have two angles. We know that they are alternate interior angles, so we can just simply set 4x minus 10 equal to 58 degrees. Okay, I'm kind of running out of time, so let me scroll down. A lot of these are the same ideas. Here we have alternate exterior angles. Those are also congruent. And then we have same side interior. Now, same side interior are not congruent, but they are supplemental. And so we know that to get the measure of angle 2, we can simply do 180 minus 66, and we get 114. And so that's 114. And then angle 1 is 66 because they're alternate interior, or these two form a linear pair. Okay? Okay, in this picture, 1 and 2 would be supplemental because they are same side interior angles. Okay? So I want to get down to this very last picture. This picture here is something that you'll see in geometry. Now, and a lot of times they won't show the lines extending. You might just see this quadrilateral here. But you can kind of extend these lines for yourself, and we see that we have two parallel lines, and then these lines act as transversals. And so based on that, we can see that x is an alternate interior angle, so it is 73 degrees. Angle y and x form a linear pair, so 180 minus 73 is 107. And then if we look over here at z, we can see same side interior angles. So 180 minus 116 is 74 degrees. Okay, so we're going to look at some practice. Again, don't worry too much if you have struggle with the proofs, but see if you can fill out some of the proofs.